Well, we're up at Panther Meadow here, bottom of the old ski ball. It's July 9th, 2012. I'm going to see if I can take a snow sample similar to what was taken 4 years ago this date by Rose Taylor. It looks like the snow is melted every bit as much as it was that year, so I'll probably have to hike up a little higher to get a sample. Of course, one thing we can't duplicate is we don't have a severe fire season as of yet this year because we did get some late rains. I'm about 8,300, 8,500, just starting to get into a little bit of snow. There's the old ski bowl parking lot below me. There's a little bit of a drift there. I think what I'll do is I'll go into this one a couple hundred feet up and then get out the shovels. We're up here between 8,500 and 9,000 now. You can barely see the parking lot down below us. Here's a nice snowdrift I'll be working on in just a second. It's fairly dirty. You can't see the summit from here. We're looking up at Thumb Rock, 12,800. If you can get there by lunch and you're not totally wiped out, you usually make the summit. We're about timberline. Of course, the soil is very loose. There's hardly any ground cover. We have a few whitebark pine up on the ridge there, and that's it. Well, the snow is about 15 inches. Well, the video is cutting out on me and it's a little overexposed, but what you're seeing here is a very dirty layer of snow on the top 3 inches, a much cleaner layer down below towards the bottom of the drift. And what I'm going to do is take a large sample, a 2-bottle sample of the dirty layer on top in order to have enough to do a total suspended sediment test. And then I'll take 1 bottle in the cleaner layer down lower. Here's a little meltwater stream below the snow level. I've got 1 more jar, so I'll take a sample here. Well, a 1/4 mile downstream now. Here is where this little creek goes underground and just starts to recharge the water table. In your typical watersheds, you have a dendritic shape with the little streams converging into bigger streams. Volcanoes, you have a radial pattern where the streams just dissipate as they go farther from the source. And of course the soil here is extremely porous. Here, just for a visual comparison, are the samples I took. Snow is melted now. 2 bottles on the left are from the top of the drift. The next one to the right. Well, the video is cutting out again, but the 1/3 from the left is the cleaner snow from the bottom of the drift, and the far right is the meltwater stream. I'm going to combine the 2 bottles on the left to get a 1-liter sample, and I'll put them all into more disposable bottles and then take them to the lab. 10 days later, the lab reports did come back. I'll try to put a snapshot in here so you can see them better. The dirty snow on the top of the drift had 11,400 micrograms per liter of aluminum. That's parts per billion. This is only about 20% of what Rose Taylor got 4 years ago. The difference might be due to the fact that we didn't have, in early July, a fire season with a lot of ash flying about. Also, the snow may be a little bit deeper where I took the sample. We lose 40 to 50% of our snow due to evaporation, and the metals don't evaporate, so the shallower your drift is, the more concentrated your metals will be. And just sample variation could account for part of that too. A professional scientist would probably take a dozen of these just to see what the random variation is. Now the snow at the bottom of the drift, however, had only 70.2 parts per billion of aluminum. That's within drinking water standards. I think 200 is, 50 to 200 is usually what's stated. And the meltwater stream had 73.5 parts per billion. For the sample from the top, I also took suspended sediment and got 796 milligrams per liter. That's parts per million. So putting that in the same unit, dividing your 11,400 parts per billion of aluminum by 796,000 parts per billion of total suspended sediment, we find that the aluminum is 1.4% of the total sediment. That is well within normal, actually a little below normal, because professional paper 1270 of the USGS said the average soil in this country has 7% aluminum. This tends to indicate that we really don't have a problem with excessive aluminum in our snow deposits. It's all on top, so it's deposited by wind after the snow season. The upper slopes of Mount Shasta is one of the windiest areas in the state.